All right, here is video 2 of our notes for today, choosing the best method. We are now going to learn what the discriminant is. The discriminant is just a fancy word for filling in this equation, or this expression. So sorry, the expression is b squared minus 4 times a times c. This expression should look familiar because this is the inside of the radical of our quadratic formula, right? B squared minus 4 times a times c. If I complete this expression, this discriminant, it will tell me how many answers I will have and what kind of answers. So notice I have this chart here. So when I plug numbers into the discriminant from my equation, and the number is greater than 0, I have two options. I have to look, is it a perfect square or not? So if it's bigger than 0 and it's a perfect square, then I'm going to have two answers, two roots. Those roots are going to be real numbers and rational numbers. Real numbers are whole numbers, negative numbers, and positive numbers. Rational numbers are fractions, so I'm going to put a fraction in a parentheses to remind me that's what a rational number is. If it is not a perfect square, so we have a number that is bigger than 0, but it is not a perfect square, we're still going to have two roots, but this time they will be real and irrational. Irrational is a radical. So I'll have perfect squares are going to give me numbers and fractions. Non-perfect squares are going to give me numbers and radicals. All right, our next one. So looking at the next situation, when d is exactly equal to 0, I'm going to have one answer, not two this time, just one. Those answers are going to be real and rational, just like when you have a perfect square. Remember, rational are fractions. And then finally, the fourth case is when d is less than 0, so negative. When it's negative, we're going to have two answers, and that's when we're going to get our imaginary numbers, which means we're going to have i's in our answer. Okay, so this chart helps us determine how many answers we'll have and what kind. This kind that we just filled in on the right-hand side, we're going to come back to that to help us choose the best method in a little bit. But first, we're going to practice just finding the discriminant and answering how many and what type of answers will we have. Okay, so we're going to plug in this information into our discriminant. Before we do that, we should identify what A is. A is 2, B is 12, and C is negative 13. Now we're going to use that discriminant formula. So B squared minus 4 times A times C. When I do this math, I'm going to get 144 plus 104, so this is 248. No, this is not our solution. This is just telling us to use this chart now and determine how many answers we have. So this number is bigger than 0. Now we need to know, is this a perfect square? I'm going to put the square root of 248 in the calculator. If I get a decimal, then it is not a perfect square. And that's true, I get a decimal. It's not a perfect square. So that means I'm going to have two real irrational answers. So that's what I'm going to write here. We're going to have two real irrational answers. Or we're going to call them roots, so you remember that roots means answer. Okay, so that's what we're looking for. We're trying to tell how many and the type of roots we have. Okay, so before we get started, first identify A, B, and C. A is negative 1, B is 16, C is negative 64. Now we're going to plug it in. B squared minus 4 times A times C. We calculate 16 squared is 256. Negative 4 times negative 1 times negative 64 is also 256, but a negative 256, so this is 0. When you have something that is 0, I'm going to have one real rational answer. One real rational root. Rational. Okay, we're going to repeat the process. First, identify A, B, and C. A is -4, B is 84. Oh, not in standard form. Can't identify A, B, and C until I put it in standard form. So, first things first, I've got to move over the 10x. Put it in standard form first, then identify A, B, and C. Once I have A, B, and C, then I will plug it into the discriminant. Discriminant is B squared minus 4 times A times C. That's 100 plus 1344, which is 1444. This is a number bigger than 0, and if you put it in the calculator and take the square root, it is a perfect square. So we have 2 real rational answers. 2 real rational roots. Okay, this last one, it's already in standard form. So A is 3, B is 0, C is 24. Plug it into the discriminant. 0 squared minus 4 times A times C. 0 squared, 0. These multiplied together is -288. -288 is less than 0. So this, I'm going to have 2 imaginary roots. Okay, so we've already determined how many answers we'll have and what those answers will look like, whether they'll have an I in it. I'll have 2 answers with I's, 2 answers with numbers and fractions, 2 answers with numbers and radicals. Okay, one more chart to fill out, and then we're going to put all of this together to help us choose the best method. So, graphing can be used only sometimes. We want to use it when roots are integers. Remember, that's whole numbers. Can we do it with fractions? Yes, but graphing is a little bit harder to be exact when you have fractions and decimals. So we want to prefer it when roots are integers. So this is normally not practical. Not practical. Because it takes time to graph it. You have to have graphing paper to plot it down, or you have to have a graphing calculator. You have to show me the information. So yes, graphing is a sometimes thing, and it's normally when you're told to graph. Factoring also is a sometimes thing, because we won't always be able to find what multiplies to be C and adds to be B. We prefer to factor when the roots are rational. So when we put in this discriminant, when I get rational roots, when I get the answer that says rational roots, I know that those 2 equations I can do factoring on. Okay, square roots. Square roots is only a sometimes thing. On that first page, we learned we couldn't use the square root method to solve that one. We want to use the square root method when there is no B term, which means X is missing. When the B term is missing, that is when it is the best candidate for the square root. And actually, you can only do the square root property when the B term is missing. All right, the first 3 are sometimes. Completing the square, we can always do. We can always do the completing the square steps. There is a preferred time when we want to do the completing the square step, when A equals 1 and when B term is even. So when A is 1 and B is even. That will make your completing the square steps easier to do. Now, when B is odd, it doesn't mean it's impossible. It just means we get fractions. And then again, complete the square. Gets a little crazy where we have fractions, but if you know on that last assignment, on the completing the square assignment, we had fractional pieces that were our factors. So even though it says this is required, because it says always, we can do it even when this is not required. But that helps you determine the preferred. Finally, quadratic formula is an always thing, and there isn't a preferred. You can use it anytime. You usually use it when others fail. Others don't work. So I go to try to factor, or I go to try to use the square root method or completing the square, and I got confused. I might switch gears and try the quadratic formula. Okay, we're now going to try to put this together in this type of chart. So here, this is all the same kind of problem. We got to do all of this at the same time. Step 1 says we're going to find the discriminant of each of these equations, A, B, C, and D. Once we found the discriminant, we're going to find the discriminant, and we're going to give the number and type of roots, just like we did in the notes above. Then from there, based on that information, we are then going to place each of these equations in one of these 4 boxes. And we can only use each method once. So we're going to use process of elimination to help us find each of the equations' placement. We want to know what is the best method in our toolbox to solve these. Okay, so to do that, the very first thing we need to do is find the discriminant, like we did on the previous page. So discriminant is b squared, so negative 9 squared minus 4 times a times c. It's going to give me 81 minus 84, so I'm going to have negative 3. When the number is less than 0, that means I'm going to have 2 imaginary roots. Okay, now that I have my 2 imaginary roots on that one, we're now going to go and find the discriminant of equation B. Okay, so in this, A is negative 2, B is 0, and C is 144. I write that down so when I do B squared, I can see that my number is going to be 0 squared. All right, B squared minus 4 times A times C. 0 squared is 0, so this is really 0 plus 1152, which is really just 1,152. This is a number that the discriminant is bigger than 0. The discriminant is bigger than 0, so now we're going to take the square root of 1,152. When I take the square root of 1,152, I get a decimal. I get 33.9. So, not a perfect square. So when it's not a perfect square, that tells me that I have 2 real but irrational roots. So my answers are going to have radicals in them. Okay, my next one, equation C. Again, we're going to find the discriminant first. So b squared, negative 22 squared, minus 4 times 3 times 7. 22 squared is 484. Minus 84, so this answer is 400. D is greater than 0. And if I take the square of 400, that is 20. So yes, it is a perfect square. So this one is 2 real rational roots. Finally, equation D. Gonna put it into the discriminant formula. B squared minus 4 times A times C. 36 plus 60 is 96. This is greater than 0, but we don't have a square root of 96. If I take the square root of 96, I get a decimal. So I'm gonna have 2 real irrational. So now we did the discriminant on each of our equations. We have the number of answers and the type of answers. We're now going to go through the list, and factoring is the most picky. Factoring, if we go back to the previous page, right, factoring requires roots to be rational. So out of these 4, we only got one that has rational roots, equation C. So I'm going to write C in the box here, and I'm going to go ahead and put equation C under factoring. Square roots is the easiest one to find. So we've already placed equation C, so I'm going to mark it off. Square roots is the easiest one to find because this is the one that's missing the B term. If we go back up and look, we want square roots has to have no B term. So the only equation that's missing the B term is equation B. It is missing its B term. So we're going to put B in for square roots, and we're going to write down equation B to solve it in a minute. All right, so we have placed B and C. We have to continue completing the square. We're going to go back up here, completing the square. The requirements for completing the square are when A is 1 and B is even. So out of the 2 that's left, A is 1 on both of them. And now we're going to look at the B term. The only one with an even term is equation D. Equation D has the even term. So down here, we're going to put D, and we're going to write equation D out. So that's x squared plus 6x minus 15 equals 0. Finally, process of elimination, the only one that's left is equation A. So equation A is x squared minus 9x plus 21 equals 0. So square roots is probably the easiest to place because it's missing the B. Then factoring, you then want to place factoring because it's the most particular. It has to have rational roots. And then from there, we can fill in completing the square and the quadratic formula. Now we just have to solve them. So solving by factoring. This is a trinomial where A is greater than 1. So we have to do slide and divide. Slide and divide. I take 3 and I slide it over here and I multiply it. So that's A times C to get a new C. So the way that looks is x squared minus 22x plus 21 because 3 times 7. From there, this is now A equals 1 where I can ask what are 2 numbers that multiply to be 21 but add to be negative 22. Multiply to be 21 but add to be 22, would that have to be 21 and 1? It would have to be a negative 21 and a negative 1 to add to be a negative, but multiply to be a positive. So our 2 factors are x minus 21 times x minus 1. Now that's our factored form, but that's not our solution. We need to solve it. So we're going to create our table, and under our table, we're going to set each of our factors equal to 0. From there, we're solving. Oh, what did we miss? Not yet. I'm just moving right ahead. Can't set our table up yet because this was slide and divide. I did a mistake that a lot of us do. We want to get to solving it. So we have to divide by A. So 21 has to be divided by 3 and 1 has to be divided by 3. So our factors are really x minus 7 times x minus 1/3. 21 divides by 3 evenly, so it became 7. 1 isn't divisible by 3, so we leave it as the fraction 1/3. Now we can create our table and solve. Set each of the factors equal to 0. Sometimes we forget to write out this step and then we do the mental math wrong. So make sure that if you're the one that ends up doing the mental math wrong, that you work through all the steps. My 2 answers are 1/3 and 7. Okay, now we're going to solve the next equation by square roots. So if we're solving by square roots, we're not getting it equal to 0 because we're not factoring. To get it to solve it by square roots, our goal is to isolate the x squared. So to get the x squared by itself, I'm solving for it. I'm going to subtract 144 over. So I'm going to get negative 2x squared equals negative 144. I then am going to divide both sides by negative 2. I get x squared equals a positive 72. I then need to take the square root of both sides. That's going to give me x equals plus or minus. 72 itself isn't a perfect square, but I can break it into perfect square factors. So if I go up the number line, I'm going to find out that 36 times 2 is 72. 36 is a perfect square, so that simplifies out to be 6 radical 2, plus or minus. We're going to put the curly brackets around it, and this is my answer. Okay. So we've solved by factoring, and now we've solved by square roots. We're now going to solve by completing the square. Completing the square, move C over first. So I'm going to rewrite A and B, a blank, add the 15 over, create a blank. We're now going to complete the square. I'm going to do that over here on the left-hand side. So B divided by 2. Square that. I'm going to add 9 to both sides. When I'm factoring, I'm going to get x plus 3 squared equals 24. Remember, whatever we squared is our factor. We're now going to take the square root of both sides. So I'm going to get x plus 3 equals plus or minus. Radical 24 can break into factors of radical 4 times radical 6. So this is really x plus 3 equals plus or minus 2 radical 6. And then finally I'm going to subtract this 3 over, but I can't actually combine it with 2 radical 6. So I'm going to have a negative 3 plus or minus 2 radical 6. Put that in curly brackets, and that is my answer. All right, we got one more, and then we're done with these notes. All right, so quadratic formula. Quadratic formula was the last thing we learned. We're now going to plug this into the formula. So the formula looks like x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, simplifying. X equals negative 9 is a positive 9. Square root of 9, negative 9 times negative 9 is a positive 81. Negative 4 times 1 times 21 is a negative 84 all over 2. 9 plus or minus, this becomes radical negative 3 all over 2. We now have to simplify that radical. 9 plus or minus I radical 3 all over 2. I don't have a negative in the denominator, nor do I have a number in front of the I that I can try to simplify this fraction with, so this is my final answer.